Hello everyone. Thank you for joining back to this training course. Um, so hopefully everyone has had a chance to go through the setup in the software carpentry course. If not, I think one provided a link in the chat. I'll post it again for those who have just joined. So for this course, we will be using Python 3 specifically, and Numpy. Which is a Python library. So both can be installed using Anaconda. And there are a couple of ways in which you can work through this course. One is executing everything through the terminal, and another one is using Jupyter notebooks. I'll start sharing my screen now. Just show you. So here you can see my terminal, and what I did, I downloaded Anaconda and I went through the installation process through the terminal. But you can also use the graphical user interface to install Anaconda. So, so if you have something like this, you can just make sure that you have a Python 3 version. So you should see something. Oh, you can see my terminal. All right. No, one can see it. Maybe it. No, right. Okay, there was a glitch there. Cool. So if you type something like this in your terminal, hopefully you will be able to see something like Python 3 and something after another version. So as long as it's higher than 3, it should be okay for this course. So you can work through the examples in this course in a couple of ways. One is just writing Python in your terminal, and you will be redirected to a Python prompt from where you can execute commands. Should work very similar to what you will see you see in the training material. Another way, just let me exit this, this Python. So I just press Control B to exit. Yeah, Python 3.7 should be okay. Oh, sorry. How to make 3.7 version Python? I see. Well, when I installed Anaconda, yes, when I installed Anaconda, part of the process did automatically set up my path. But yeah, I think one Tom suggested that you can use Python 3 as a workaround. So let me just see. Yes, and you see something similar. So there are a couple of ways depending on your system. Could be also, instead of 3, could be Python 3.8 or 3.7 or 3.6 depending on your installation. In my case, it could be Python 3.8, and any of those should work in your terminal. So, but the alternative way is to use Jupyter notebooks. So if you install everything through the graphical user interface, and if you open Anaconda, you will see a window where you have several options to open different applications. One of those will be a Jupyter notebook. Let me see if I can change tabs in here. Yes, if you use a Jupyter notebook, you will see something like this, depending on where you are located in your directories. So in here, let me just bring the desktop. So I am on my desktop directory where I have a few directories already and a couple of zip files. So you can see that this is exactly the same as in my terminal. If I just do an ls desktop, you can see exactly the same. So I am in the same. If I jump to desktop and clear my screen, you will see that I am in exactly the same directory as in my Jupyter notebooks. So either of those, you can use either of those for the examples in this course. So in as I showed before, on the terminal, you can just write Python or Python 3 to enter a Python prompt that will let you work with examples. If you are using Jupyter notebooks, you need to do something slightly different. So assuming that you are in a directory like this, where you already downloaded the code and data files, have you downloaded those files already? If not, should be on the setup website. If I just show you, yes, no problem. I posted in the link, and I'll. So part of the setup is installing Python and obtaining the lesson materials. So in here, you can download these two zip files to your desktop directory and extract them. You should see a couple of directories, new directories. Optionally, you can create an SEW Python on your desktop. I think I didn't do that on my own directory structure. But in the end, you should see a couple of directories called data and another called code. So hopefully you can do this step. And so in the end, you should see something like this: a couple of files that you downloaded, and that your new directories code and data. So we will be working mostly with the data directory at this point. So if you change into that directory or you open it through Jupyter Notebooks, you will see something like this. And at this point, you will need to open a new Python session. So in here, if you go to the top right corner, you will see upload and new. So if you click on new, you will see here you can create a new Python, new notebook using Python 3. So you click on that. You will be redirected to a new tab that looks like this. For those using the terminal, you can just type Python and you will be redirected to a prompt. So let us start then. I'm not sure about the background of the different students of this lesson. So the course is mostly assumes that you don't have a lot of experience programming. So it starts with the very basics. So one of the advantages of Python is that it lets you it's a very interactive programming language. It can be used as a programming interactive language. So, for example, you can do some calculations. Let me see. Let me just to check. Is the font okay? Is it too small or is it readable? Let me know if that's not the case. So on Python, you can do. I try to make it bigger. Let's see if this works. Let's see that. Right. Let's see that if that works. Okay. So if you execute this, to execute commands on the Jupyter notebooks, you need to do Shift Enter, and that will execute whatever commands are in this cell, and gives you an output, and it will create a new cell for you to input new commands. So Python can be used just to process simple mathematical operations, and that's useful in some occasions. But you probably need to do some things more complex. So typically, operating programming languages use things called variables. So variables is just things like labels for data. So if you wanted at some point to refer back to some data entity, you can give it a label. Like for example, if I wanted to define something weight on kilograms, I can do it like this. So in this case, I'm defining a variable called weight underscore kilograms, kg, and I'm assigning a value for this variable with this operator equal sign. So in this case, for this to work, I just need to do a Shift Enter, and you won't see a lot. But now internally, Python is holding this value 60 on weight underscore kg. So every time I refer back now to weight kg, the value 60 will be replaced, or any value that I have assigned will be replaced in place of weight kg. So that's important. If for those of you who have experience with programming languages, maybe this is very simple, but you should be aware of some differences with other operating languages. So, for example, you can include letters, digits, and underscores on the variable name, but you cannot start a variable with a digit. So I couldn't do something like 1 weight in kg. That wouldn't be a valid variable name. Sorry for the typos. Our variables are case sensitive, so something like weight kg would be different from something that starts with an uppercase W. So there will be two completely different variables. So that's something to have in mind. That might be different from other programming languages. So as Python, also something that is different from other programming languages is that in Python you don't need to specifically define the type of your variable. You don't need to tell Python if something is an integer or is a float or is a string. Python automatically does this for you. Python can handle integer numbers, floating numbers, and strings easily, but without you necessarily defining them, specifying the type. That's simple, but it can be a bit confusing for people coming from C or C++ or Fortran backgrounds. It might take some time to get used to that. So how do you use variables? Once that you have defined a variable in Python, how do you use it? So what you can do is just refer to it. Use the label that you created. So the name of the variable. So for example, we'll be using a lot this function. This function will print to the screen whatever I gave it as an argument. So to give arguments to functions, you use these brackets. So if I type wave and I hit my tab key, so in many depending how you are running your how you are running Python, this might work or not. So if I partially delete the variable name and I hit my T tab, you will see that it auto-completes. So Python keeps track of what it has been defined in your environment. So by hitting tab, it will try to auto-complete with those options that are available. So in this case, it's only one, so it auto-completes with weight _kilograms. Should be no space in the command. Sorry, which if I'm not sure I understand the question from Dinesh, there should be no space in the command. If I execute this command in here, sorry, Dinesh, you're referring to the print command that I just used? Oh. You can use spaces, I believe. Let me just see. I don't know exactly if this is what you mean. Like if I do use spaces in here, let me see if I can execute this. It will work as well. So for Python, for some functions, especially for print functions, there are certain grammar. So, and this is a very gotcha for some Python users who are used to work with Python 2. Moving to Python 3, one of the first error messages that they find is that the print function is slightly different between those two Python versions. But in general, the spaces in this situation, this specific format doesn't matter that much. Yes. Okay, moving on. So another way you can execute print or use print is, so at the moment I only provided one argument. Print can accept more than one argument. So for example, if I define another I can define another variable, like for example, wait. Text. So I'm defining a variable that will hold different kind of type. So in this case, I'm defining a variable that will hold something in string format. So nothing happened there, but this variable now holds this string internally. So and I can use it now with my print function, and I can use wait, and if I hit my tab key, you can see now that Python gives me two options because there are two similar variables defined in my environment. Again, this might work differently depending on how you're executing your Python. So in this case, I can select this one, but print can accept more than one argument. So I can tell print that I want to print more than one thing. So I just use this comma symbol, and then I want to print my second variable. And if I hit Shift Enter, that will print this. So it printed my string that was inside, defined it in weight underscore kg underscore text, and then it printed 60. That was the value for weight underscore kg. So that's how print works and how you can use multiple variables within the print function. You can use other operations also within print. For example, if I do print and I just basically repeat what I was doing. Actually, let me just show you how you can reuse a cell. So let me just delete this, and I will just go back into this cell that I just used, and I can just modify the content. So if I do this and I do 2.2, so what I'm telling Python is first to do a mathematical operation with this function, with this variable, and use the result as an argument for print. So if I go ahead and I do Shift Enter, you can see that the operation was performed and the result value was used for print, for the argument of print. So that's possible. You can also do that. But again, doing this previous operation, weight that I multiplied weight in kilograms by times 2.2 didn't affect it in any way the value for that was stored in weight in kilograms. It still holds the same value. And if I wanted to change that value, I just need to use again the assignment operator, that is equal sign. I can change it to something else, and that should be fine. And I can just now use print, and I can just directly tell print that I want to print some string. There's a bit of lag in my terminal at the moment. And if I click at this, you will see that now I successfully redefined my variable. So those are some of the basic concepts for how variables work in Python, and we have been also using a basic function that we'll be using a lot through this course. That is the print function to print results to the screen. So you will see also in the training material that there is something that is called using this hash symbol, and this is used for comments. So Python will completely ignore whatever comes after the hash symbol, but sometimes it's useful if you were working with if you were writing a script and you wanted to leave some notes for your future self, or for somebody else who were to be reading your program after. you want to share with somebody else. You want that person to understand what you were doing. Comments are a good way to achieve this. So if you want to create a comment on a Python program, you can use this symbol, and whatever comes after will be ignored, but will still remain there as text. So I think those are the basics for how to define variables. If you have any doubts, please put them in the chat. We'll try to answer them. Let me move to next topic. So now I think it's a good moment to start explaining what the data that we downloaded and the setup process is. So data, let me just go back to my setup command. If you were to open one of those files in the data directory, you will see something like this. So several numbers. Let me just increase the font. You will see something like this. So files with numbers separated by comma symbols. So these are comma separated values, which are also called CSV files or CSV formats. So what it means here, these are just the three first rows in one of these files. So what the file, what this data mean, what it's supposed to mean is that this is inflammation, is representing inflammation in patients. So every row in the file represents a patient. So patient, first patient, second patient, and third patient, and then every entry, every column, it's the daily inflammation. So it will be inflammation for patient 0 on the first day, inflammation level of inflammation for the first patient on the second day and the third day, and so on. So this is what we have on our data files. Okay, so that's what we have at the moment. Let me just go back then to my Jupyter notebooks. So to work with these files, we will be using one of Python libraries called Numpy. So the way it works is that Python by default can do very useful things like multiplication, arithmetic operations. You can find variables. You can work with lists. You can do a lot of very useful things by default with Python. There are defined internally within the Python programming language. However, people have creating libraries with more useful commands and instructions, and that people have saved all of those instructions or functions in things called libraries. So these are like a way to extend the functionality of Python. So there are different kinds of libraries for many different purposes. So one of the most used libraries is called Numpy, and it's a short for numerical Python. So so this library, one of the things that let us do is that we can work with arrays very easily, and especially in files like are comma separated, or it has some sort of a homogeneous distribution that if they can be comma separated, space separated, tab separated. These kind of files are easily worked with Numpy, and in this lesson we will try to show you how it is done. So the way that you make a library available in Python is that you need to use the word import. This tell Python that you want to load that library into your work environment. So if you do import numpy space import space numpy, and you hit Shift Enter, and you won't see any message. That's typically a good sign. If there was any problem loading that library, you will see some sort of error message. But in this case, it was successful silently. But now that you have it, you can actually use it. So the way to use it is you can type numpy and then add a dot. So the way to access the different functions within a library, module not found error, module name bumped. Yes, that's kind of the error that I was worried it might happen. So that means that you didn't install, probably you didn't install NumPy as part of the installation process. Depending on how you installed Python, you might need to necessarily, you shouldn't need to reinstall Python. You might just need to install independently NumPy. How did you install Python? That would be the first question. Just Python, not through an account, I suppose. Yeah. So yeah, maybe you will need to find instructions then to build NumPy by independently. So yeah, it varies. The process to install the libraries vary depending on in which way Python was installed. So Anaconda is the recommended way because it handles most of the common situations, and it also has an internal package manager that will help you install most of the common Python libraries. So, well, hopefully you can our helpers can help you find the best solution. But for the meantime, I'll carry on. So as I was mentioning, we just import NumPy, and from this point on, we can start using it. And the way we use it is we just refer to its name, NumPy, and the way we access the different functions within a library is we use a dot. So this will tell Python that we are actually what comes after the dot is part of the NumPy library or whatever library you're using. So in this case, if I do load text, that's a function within the NumPy library. And actually, if I just erase it, if I just do load and I do hit tab, you can see that it's actually giving me a few options. Again, this might vary depending on how you're running Python. It might be that it doesn't display like this. It might be it displays in a different way, or maybe you don't get any display. Jupyter Notebooks, it's useful in this sense because it gives you this nice interface that you can see. But other IDEs or maybe Python through the command line might offer similar functionality. So, and you can if you're not sure what the function does, you can find help. There are a couple of ways you can do this. So the way in which Jupyter Notebook works, you can add this question mark symbol at the end. And if you hit enter, Python will show you some documentation about this function. So including the name of the function and the different arguments that it accepts, and a description of what it does. So in this case, it's load data from text file, and well, more detailed description of what it does. If you want more details. I think in the terminal you might need to use a different way. There's I think it's through help. Through this help function. Let me just see if it works in here. It also works in Jupyter Notebooks. So it also it's not exactly the same, but it's a very similar output. So let me just now do what I was doing before. So this was also how to try to find out what the function does. But in the thing that we know that this function actually loads text from a file. So what it requires is some arguments. So in this case, the file name that is given by F, and in here, and if I hit Tab after just dragging a few characters, Jupyter Notebooks displays few options because these files are in my current directory. Remember that I am in the data directory. So for that reason, it shows me what the different options are for files starting with infla. So if I just pick one, in case you don't get any sort of suggestions, you will need to type the complete name. So depending on how you're working with Python, you might need to do that. So, and it will also, I also need to provide this function how the file is delimited. So this file is delimited with this symbol. So the different columns are. I need to use this this file here. So that if I do hit enter, there is a question on how to change directory through the notebook. How to go to the directory in the desktop? I see. Right. What I did at the beginning. So my original notebook was showing something like this. And here you can see where you are located on this part of the notebook on my original tab, and on here you can navigate. I was in here, and I have all display of all my directories. And if you click on data, then you jump into that directory. And if you execute your notebook here, you can your notebook will be executed from this directory. That's one way to do it. The other way to do it is, as Juan mentioned, you can actually provide relative paths. So if you were on a different one level up, you can do this. You say data, and you can provide the relative path. So this should work, depending on where you are, obviously. If you are in a directory containing the data directory, you can access the information data like this. Data and then / and then information. So this is a how you will provide the relative path in Linux systems. So in Windows, not sure if exactly the same, but hopefully there is an equivalent way to access relative paths. So let me just do this. Right. So now Numpy loaded this text, but it just at the moment it's just displaying it into the screen by default. So, and it's showing me what it is. So it is an array, and it is showing me in this way. And what this means is it has several rows. You see this one, for example, is the first row of my data, and you can see that because it is divided by square brackets in here. So here's one square bracket, and here's the closing square bracket, and then you have a comma, and you have a new opening square bracket and a new closing square bracket. So those are my rows, and you can see here 3 dots. So what those 3 dots means is that if you have too many files, or your file, each row has lots of columns, Numpy will just show you the first entries of the first columns and the last ones. Whatever in between, it will summarize it, or won't show it by default, and just show you 3 dots, and that's it. In a similar way, going row by row, if you have so many rows, it won't show you all of them, so it will show you 3 dots in between. So this means there are more rows, and it will then jump to the last 3 rows. And then you see that there is another second closing bracket that matches this one. So that means this is similar to a matrix, or it is an array. So this is internally how Numpy is loading this data file, this text file. So now we actually in some documentation, if you look for documentation on Numpy, you might times find it like this. Let me just do Numpy. I won't be executing this, but just want to mention that if you look for help for Numpy online, sometimes you will see something like this: import Numpy as np, and this is just it's the same, except that you're now defining Numpy as np, so it's just a shorter name, but everything will work the same. Just that instead of referring to Numpy before, numpy.loadText, it will be np.loadText. But everything is the same. It's just a more convenient way to refer to long to libraries with long names. So that's why I want to do it. So let me just delete this and carry on. So as you saw here, I didn't actually. I just loaded the file, but I actually didn't do anything with it. There is an error. Somebody has a problem. I think you have a 3 after f name equals. There is an extra 3 that maybe shouldn't be there. So as I was saying, I didn't do anything with that data that just loaded. So Python just loaded and printed. But what if I actually want to do something with it? First, I need to assign it to a variable. So I can do this with this. So with the assignment with the equal sign, and then do exactly the same. Numpy dot load text, and then f name. There is lab, yes, and then equals. The file name is information CSV, and then delimiter, and then hit a comma. Now, if I execute this, you don't see anything being printed because the array now is being saved on this variable data. So now, if I do print data, you see that I have the output that I had before. But now it's not showing me actually the type. It's just showing me the content. So it's just showing me I'm storing this this data in here in this format. But what if I want to know what type of data, what kind of data is data holding? What you can do is to print and use a different function. Type data. So you see here, type also uses two brackets. So opening bracket and other closing bracket, and then on top of the print brackets. So if I do this, the message is that the type of the data class is a Numpy and array. So it's just telling me the data currently referred to an n-dimensional array. And this kind of data, it's for Numpy. That's why it's telling me it's a specific Numpy and the array. And you can do something there with other variables. If you were to substitute data with a string, a variable containing a string, you will see something, a different messaging here. It's telling you this is a string type or something else. So, but this is telling us that what is the type of data. What if we know instead what kind of data is contained within the variable? In this case, data. So in that case, I can do print and do data. So data being well, array type, Numpy and the array, it has a few useful internal functions. So how can you access those internal functions? It's very similar to how you access library functions. So the way you do it is you use a dot, and if you hit tab a couple of times, then again, this depends on how you use in Python. It will show you several options of all the different functionalities that the Numpy arrays have. So just for demonstration, I will using d type. That's that data type, and if I hit that, it's telling me that data is holding floats numbers in the format of float 64. And you can do something, you can use any other function. Like now, say if I want to, I want to see the shape of this array, meaning how many columns, how many rows it has. I can use shape. Hit enter, shift enter. It is telling me that it have is 60 by 40. So I have 60 rows and 40 columns. But there's so this is the way how you can access the different functions specific for ND arrays, Numpy arrays. And again, if you want to find more about what a specific function does, or specific feature of Numpy arrays does, you can do something like this, and it will tell you more about that specific feature. Or using help help function. So, okay, that's a bit about the basics of NumPy arrays. How do you interact with individual values within your newly defined array? So you can do this. You can do something like if we do something print and do, let's say, first value in data. Like data, and I want to use print my first value. I hit Shift Enter. You see here that my first value is 0.0, and that is that seems correct. If you see above I printed the whole content. Seems like the first command, the first element was actually 0, so that seems correct. And I can do similar things, like if I how do you print multiple lines? One way to do this, say I want to do. Actually, I can do it in here. If I do it in here, I just hit Enter. Sorry about all. You meant is it printing multiple lines in Jupyter Notebooks, or is it in the command line? So if I want to print another value, say the value in the middle, then it will be 30 and 20. Then I hit Enter. You can see now I have a different value specifically for that in that position. So that's how you access data on your array. That you can access specific data. So one thing that you might, depending on your background, you might be surprised about a bit about how the numbers are, well, how the data in the array is numbered. So for starters, like first thing is we access it starting at 0.00. So that's the first position in my array. That might be maybe surprising for people coming from Fortran or R, maybe MATLAB, where indices start at 1. So it might be familiar with other programmers that comes from C or C++, but actually they are numbered starting at 0. So those are two ways how to number elements in arrays or matrices. But that's the first thing. Second one is that you actually saw that my 0, element was actually on my left top left corner. Well, actually, both are the same, but the way it works on Python is that the first element is starting here on the top left corner, rather than, for example, if you were expecting something more like Cartesian coordinates, you might have been expecting something starting here. So it's more similar to how matrices are. How do you work with matrices? So just a couple of things to have in mind.
Jose?
Yep.
Dines has a question. I think has the raised hand.
Oh, sorry. I was looking at the notebooks. Sorry, Dinesh.
Do you want to mute yourself, or?
Yes, we go ahead.
Or you can ask the question via chat.
I think is it the question that is in the chat? There is a, I don't know if that was.
somehow is different. I don't know how it got missed because I made the desktop. I put the file in desktop with the name that suggests. I don't know because in the page it shows a different path.
Sorry, the connection dropped for a bit. I think.
Yeah, like as you mentioned in web page, I put the data in the folder in the. I don't know how to
Yep.
load web page, the Anaconda web page where we are inputting the comments. The Jupyter Lab, yeah. I'm not able to locate the file there because I don't know what are the located. And I see
Yeah.
there is a folder, but it is having different data. Probably the web ones, I
Okay.
don't know. Yeah.
Right. Did you download the file from the setup tab? Did you download these two zip
Yeah,
files?
yeah.
Okay.
Yeah, I have downloaded them. Yeah.
Okay. So if you executed your Jupyter notebooks, it will show you something, probably something like this at the beginning. You will be located somewhere in your directory structure by default. I don't know if you saw something like this.
Uh, I'm not able to see like this. There is a set of folder already existing there. So yeah. So there is an upload option. Should I upload it like or I don't know whether
Not
I'm in a
necessarily.
different lab. Yeah, actually, the one which you said.
Are you able to see something like what I have on my screen at the moment? Like anything resembling this, like not necessarily the same files, but are you able to see directories?
Yeah, I'm able to see that, but I
Okay.
don't have options to go back.
To go back, you
Can you
can.
see you have an upload thing, no? Or after that you have new.
Yes. Okay.
But I have a upload arrow mark. After that, it's a refresh button. So it's different from yours. Actually.
I see. So in the case, I'm unsure. What would be the
What
best
we can
way?
do is we can see that we can go to a breakout room, Ines, and we can see how we can solve it. That's right for you? That's okay?
Yeah, that's okay. Yeah.
Yeah,
Okay.
I do
Thank you.
that. No, you can continue, Jose. Thank you.
Thank you, Juan. Let me just go back to here, and so let us carry on. So we're just showing you how to access data using a bit Numpy arrays. So just a bit about how they are stored, how to access different functions, how to get some more information about specific functions, how to access specific data. So now, but there are other useful things that you can do with NumPy arrays. And I'm still here, yes. So now, if I do print, say for example, I can slice my data. So do that. What you do is, for example, if I do this, let me just show you what will happen, and explain in a moment. So it prints something like this. So what it just did is, so my first argument here, it refers to the rows. So by doing 0 colon 4, it's actually saying I want to print the first 4 rows. So starting at 0, that's the first row, then row 1, row 2, and row 3. So it doesn't include the 4th row. And that might be confusing again for people coming from depending on which programming language you're coming from, or if you're just not used to, starting counting thing at 0. So it starts at 0, and runs up right before the last number, so from 0 to 3 actually. And similarly, the second argument here is telling print only the columns from 0 to 9, so 1 before the name that we provided here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are 10 columns. So hopefully the text might take a bit of time to get used to that way of working with an arrays, the indexing of the arrays. But in the end, you will probably become familiar. But again, this is how you slice. You can print the slices of your data. If you're interested in specific sections of your data, you can access them like this. So only printing the first 4 patients and for the first 10 days. So this is specific section. You can access it in this way. But since I'm doing another way to do this is that you don't need to start at the beginning. You can just start somewhere else. Like if I want to see the patients in the middle, like from patient 5 to patient 9, and that's why I'm using timing here. I will print something different. And if you were to open your text file, you will be able to compare that this is actually the information for patient 5 to 9, and for the first 10 days. So you can also, if you were starting at 0 in here, if you want to see information for the first 3 patients, you can do it like this, as we showed before. But you can also, if you're starting at the beginning, you can just drop the 0. And if you're using colon 3, Python will get that you are actually referring that you want to start from the very beginning, from the top row, and it will print exactly the same. And you can see. Similarly, if you want to just see, for example, the last 4 columns, you can just drop the second argument here in the columns part, and just do the column symbol. Python will get that you are referring that you want to run from 336 to the end, and that's what will print you that. So that's a few ways that you can slice data. So other nice features of Numpy arrays is, as I mentioned, as I showed you before, Numpy has different functions. So let me just has different functions that you can work with. So in particular, we will be using 3 of them to try to get some statistics out of our data. So if I wanted to get the average value, the mean value of our data, I can use, there's a mean function. Well, it has a lot. So let me just start with m. So just to filter out those that start with an m, and I hit this one. I want that mean. If I do this, the numpy mean, and the argument that it takes is on a numpy array. So this mean function will calculate the mean value within an array. So data is an array, so that will work, and it will go ahead, calculate, and it will print what is that value. and I can do similar things with for other functions. Like for example, I can do for numpy dot max, and again it will take data as an argument. But let me just print this for now, and it will look among all the data and will print what is the maximum value. In this case, it turns out to be 20. A nice feature of Python is that I can assign multiple values at the same time. So, for example, I could do this. Max, I will define 3 variables at the same time. So, max val is one of the variables I want to define. Mean value is a second variable that I want to define, and then estimate value, standard value, standard deviation value that I want to define. So, and after those three variables, I use the equal sign, and I do what are the values that those variables should get. So in this case, I do max data. So the result from this function will be assigned to the corresponding variable name here. So then the second one will be numpy dot mean value, and yeah, and then numpy dot with a flag test data. And if I do that, I got an error somewhere. Probably I didn't type something correctly. In here, data, and there is no output. That's fine because all the values were assigned to those variables. But I wanted to print them to maximum. I'm struggling with the flag information, and let me I will just copy this just to save a bit of time with the typing. I will so this main value of dt sound or minimum value. So here, hopefully, I get the values that I got assigned before. So this is a nice feature for Python. It's not specific to NumPy. So Python allows you to define multiple values at the same time in this way. So what you have at the other side of the equal sign will be the values that, the values that coming after the equal sign will be assigned to the corresponding variable names on the left side. So far, all the functions we have used take an argument. So, like for example, print will take an argument in here. For example, you want to print, you will put the argument between square and brackets, and similarly for calculating the maximum value on using NumPy and on the other functions that we have used. However, not all functions need arguments to be provided. So, for example, if we were to use a different library, let me just import a different library. In this case, this library is called time. And if I do print time, and I will be using a from within that library. So this is a ctime function, and this function doesn't need to take an argument. So, but even though I don't need to provide an argument, I still need to give the these brackets, because that's how functions work in Python. So if I do this, you'll see the function goes away and produces a result. In this case, it provides me the current time. But this is just to show you that not all functions require arguments, but even though they don't require arguments, you still need to provide those opening and closing brackets. Because you will probably find several instances where that happens. Right. So, as I mentioned, so far we have been working with the whole data, with the whole array. But maybe some point you want to work with a specific subsets of your data. Like, for example, if you want to work with extracting specific information from a patient, you can do that. For example, if I want to do patient 0, and you can do data, and you can extract the data from from our main array. So this will extract the first row and all the elements that belong to that row. So this column is just says start from the beginning and run to the end. So it will extract everything for the first row. That's the first patient. So now patient underscore 0 has the information from the first row. And if I were to type this, let me just print, and I will just do this max instead of I'm not writing the whole message just to save a bit of time, but I will comment it with my tell you what this is for. So so now I use print numpy.max patient 0. This is actually printing the maximum value, the maximum inflammation for patient 0, because patient 0 holds the data for all the days for patient 0, and I'm just trying to extract that maximum value. So before we were doing getting the maximum value for all patients. Now we are only restricting this for patient 0, for the first row. And you can do something similar for other patients, like say you want patient 2. You can do exactly the same, or very similar data, then 2, and from here you can do something similar. So in this case, it will take patient 2 and all the values for that patient, and you print. So if you print numpy.max patient 2, it will give you that the maximum inflammation value for patient 2 was 19. So now there is another well, maybe a good moment for a break. At this point, I think the break was scheduled at this moment. I don't want to break the program, so might be a good moment to stop, and and let you ask any questions if you have any at the moment, specifically with the setup. So Juan, would it be okay if we break at this moment? Okay. So I'll see you back here at 11:30. And in the meantime, Juan and me will be around. If you have any questions, please put it in the chat. And yeah, see you in 15 minutes.